welcome to week 10. If you guys take a look, you'll find that there's only 2 assignments for this week. The announcements there are on the top, and of course if you guys go here, but I'm gonna highlight some of the websites and the interactives you need to go through because they are a little bit different than maybe what we've used before. So I'll try to go through those here in steps. So the first assignment is Newton demonstration examples. So if you guys go here and you open the link, it'll ask you to make a copy and it will bring you to a document that looks like this. So in this document you'll see that there's basically 2 parts, but what you guys are doing is you are trying to research videos that demonstrate Newton's first law, second law, and third law. So when you find a video, and again YouTube is probably your main source for finding a video, but it's not the only source. But if you do find a video that's on YouTube or some other place, you guys are to insert the link here. You should state what law it is. So here's Newton's first law, so you should state what the first law is. The materials needed to actually complete the demonstration. So not that you have to physically put this together, but in the video, depending on what they use, then it shows a diagram of the demonstration, also in parentheses insert the image. So show me what the picture, or show me what the apparatus looked like. So if you have to pause the video and take a screenshot or something like that and insert it, but just show me, what did they set up, what were they really trying to do. And then at the bottom here it says an explanation of how the law is demonstrated. So this is you verbalizing how Newton's first law was demonstrated in the video, or maybe if it was, hopefully. So 3-sentence minimum for this. So again, when I'm grading this, if you have less than 3 sentences, or for example you didn't put an image in here, then you would be deducted points. It's going to be the exact same thing for Newton's second law. Insert the link, state the law, the materials needed, diagram, or insert an image, and then describe how it's related. And the same for Newton's third law. So all of that will be completed right on the document. Part 2, you'll kind of be doing this simultaneously at the same time. As you're searching for videos, if you just search Newton's second law and find a bunch of videos, I only need you to include one in the upper portion for part 1, only one that you have to describe and insert an image and everything else. But I would also like you to find at least 3 additional examples, just the videos. You don't have to do explanations or anything, but if you find something that's kind of cool, something that you find interesting, I would like you to include the link. What I will do in the future is make a kind of a collaboration or a compilation of all the different video links for Newton's laws. So that's the first assignment, so that one shouldn't be too bad. Your second assignment, so this was the Newton demonstrations. The other one is Newton's laws online simulations. If you guys click this and open it, it will ask you to make a copy of a document which has many more pages to it. It will look something like this. And there's a link right here. If you guys click on this, it will bring you to phetcolorado.edu with a whole bunch of other stuff after it. If you open this link, it will bring you to an interactive that looks like this. Now this interactive has net force, motion, friction, and acceleration, all as various interactives we can use. For the first half of the assignment, you're going to be using the interactive that says net force. So it will look something like this. As you go through each of the problems or each of the questions, I'll show an image or the diagram of what you're doing in the interactive, and it's going to ask you some basic questions. For example, what is the force value of a large person, a medium person, and a small person? So in the interactive, you just kind of got to play around with it a little bit. Take one of the larger people and put it on the rope, put one of the smaller people on the rope, put the medium-sized person on the rope. The upper right-hand corner has these boxes. You should check all the boxes. So it'll show the sum of the force, the values, and then the speed. So this is showing the net force. They say sum of force. It's the same thing as the net force. So after all of these forces have been added together or subtracted, it will tell you how much force is really acting on the cart. So again, placing one person, what's their force, large person, medium person, small person. And I think it's fairly self-explanatory as you go through. There's a lot of different ways that you set this up, and you're going to just be, again, answering the information that's given to you in the interactive. So there isn't so much math involved. It's more conceptual, just kind of looking and seeing how forces are summed up and the results of them. So for the first 5 examples, I believe, you're going to be using the same interactive, the force interactive, so the one that we are looking at here, the net force interactive. However, when you get down here a little bit further, when you get to problem number 6, this says go to the bottom of the interactive and open the motion simulator and answer the following questions. So this is a little bit different setup. If this is the net force, if you scroll to the bottom where it shows motion, if you click this, this will give you a different setup. You're going to be using the same toggles in the upper right corner, force, values, mass, and speed. This has a pause and a start button, so you can play the interactive. I suggest all the time is putting this on pause to begin with, because as you add force, you can change the value down here either with the slider or with the arrows. So the larger arrows add and subtract newtons in terms of 50, and the smaller arrows add and subtract in terms of single digits. So if you're looking for getting specific numbers, I would suggest doing that. But for example, if I apply some force to this and I want to start the interactive, you'll start to see the speed and acceleration, everything will start to happen if I hit start. So you can start it and stop it in various locations. The one thing that this interactive does not have that you will need at some point is you're going to need a stopwatch. So I know there's online stopwatches, but the problem with that is it's really difficult to start and stop an online stopwatch while you need to basically click the start and stop button up here. So my suggestion is to use maybe one on your phone. Most phones have a stopwatch on them, or if you have a stopwatch at home, or you can even use, in essence, you could use a wristwatch or something like that. You're going to need to be able to time 10 and 20-second intervals for some of the questions. So you will see there's, part A and B for most of these setups, so I'll have you either add or subtract, mass. I will have you add or subtract force. You're going to take measurements of time and see, how much the velocity changes over given amounts of time. And again, there will not be really much math for you to do. It's just taking some measurements and observing how things accelerate or decelerate or speed up or slow down based on masses that are there. So this one will take a little bit of time, but it should be hopefully kind of fun, a little enjoyable, and not a lot of, you don't have to set up materials and send me photos of anything because it's all right here. So that's about all I got for you guys this week. If you got any questions, please let me know. Email me, or you can stop into my classroom and see me. Schedule an appointment by email is preferred. Otherwise, take a look at the syllabus and check the class times that I'm around. Thank you very much. You guys have a good week.